We are going to recycle yesterday's aerial footage from the Monday supporter video because it's just too windy. We've got 30-mile-an-hour winds here blowing around. Let's take a look and see what's causing that. Here we've got the surface map showing a surface low in the Texas Panhandle. Cold front extending down into far west Texas and into northwestern Mexico. To the west of that, you can see the cold air filtering in through Arizona. It's modified quite a bit, but temperatures are in the 50s there in Arizona and dropping off into the 40s and 30s in Nevada. Out to the east, we've got a warm front lifting north through Texas, and look at that warm air coming up from the Gulf. Temperatures in the 70s with dew points around 60 in San Antonio and Corpus Christi. And we can see north of that front, it is quite a bit cooler, especially up in Kansas, where we've got 30s and a few snow bands all the way up towards Minnesota, out through Sioux Falls and down through Grand Island, out to Topeka. And I would say there's probably an inverted trough running something like that maybe. It's kind of hard to pick that out, but it's going to be right in that area. The East Coast showing a 1036 millibar high over upstate New York. On the east side of that, we've got cold air flowing down into New England. 37 there at New York and about 40 in Washington, D.C. And then, of course, up in the Arctic, we got to check that out. Not much going on. I don't see any existence of any strong Arctic highs. It looks like the cold air that exists up there is getting advected into the backside of this baroclinic system in Coral Harbor, and I think that is transitioning into an occluded system. I'm guessing at the frontal locations here, but yesterday we were looking at some very warm temperatures up in the Labrador Sea area. The Greenland coast had temperatures near freezing, 20s and some 30s, and Thule, which is typically very cold this time of year, they were showing 20s yesterday, and now they're down to 10 degrees. But this all looks like the heavily modified warm sector, and down to the south, the cold sector. And then the thickness and pressure chart. Maybe some of you are getting tired of seeing this on every weathercast, but I think this is one of the most important tools, maybe overlooked by some forecasters, because this shows the distribution of the air masses as well as the pressure systems. And today, to mix things up a little bit, we'll use the charts from Tropical Tidbits, some great products at that website. You can see that the cold air mass covers most of the southwestern U.S. That's because of that thickness troughing showing up right in this area here, where the thickness pattern bends southward, and it's part of this other blob of cold air in the northern plains. Likewise, where we have thickness ridging, that indicates warm air. Now, a lot of it is overriding the warm front down to the south, so we find that aloft. But down to the south, it does meet up with the surface, and we see that as a warm air mass from the surface plots. And of course, south of the gradients, that's where the fronts are. There's the cold front, and then the warm front is going to be located up at this triple point here, extending east into Alabama like that. And this is that inverted trough we were looking at earlier. That probably does have some frontal characteristics. Could carry that as a secondary front, perhaps linking back into that other area of cold air coming south through Colorado. So that's how we analyze that system there, looking at the thickness chart. Do we see any other features? Not really, just some weak warm air advection. In Washington, D.C., looks like the main low is well offshore. And then we've got this baroclinic high. We call it baroclinic because we can see the thickness ribbons going right through the middle of that thing. Now, of course, the thermal gradients are going to spread apart in that divergent flow. So we're not going to analyze fronts in this area, but off to the east, yeah, definitely. Looks like maybe a cold front right there, and you can see very strong cold air advection along the continental shelf right there. And to the north, very cold air across the Canadian Maritimes into Quebec. And as far as the precipitation fields, we're seeing that snow coming down, the model-produced snow. It's got those snow bands through Iowa, Minnesota, back into the Dakotas, and then it looks like an area of maybe sleet, maybe some freezing rain there in southern Iowa, and then rain all the way down into Kansas and Oklahoma. So we'll look for that on the surface chart. Now that we have a very solid understanding of the thermodynamic structure of the air masses and where the jets should be, let's look at the actual data, and this will give us a more refined picture of where all these features are. Now, this is the Aviation Weather Center METAR plot, and I sometimes get kind of in a hurry using these websites, but I found this button right here, and that lets us expand the map and actually zoom in. So that looks pretty good, doesn't it? So maybe we'll use that for our analysis. So we're looking at current data here for early evening. So let's start out taking a look at the weather in West Texas. We see westerly winds through all of New Mexico and parts of far west Texas. Marfa there still showing southerly winds along with Fort Stockton. So the front is probably going to be right in this area here. You can see not really much of a push of cold air behind that front, and it looks like the Canadian air has not really arrived in that area yet. It does look like a boundary, maybe from some early convection up here in northwest Texas. And as we pan further up the frontal boundary, this is what I'm guessing might be a little bit of outflow or something. That's definitely not tropical air. Now further north we can see that Canadian air coming down from Colorado. Leading edge of that cold air, that's roughly like that. So strong north winds at places like Trinidad, Springfield, Elkhart, and Garden City. So that's going to work into the Texas Panhandle later this evening. Out in Kansas, it does look like we pick up that inverted trough. I think that might connect back up into western Oklahoma, something like that. And it looks like it divides this stagnant Canadian air with northwesterly flow from this region of cool air undergoing warm air advection down in Oklahoma. And let's take a look at that. So here we're looking at Oklahoma and North Texas. We've got southerly flow setting in. It's still pretty mild there in Oklahoma, but temperatures are coming up. And that front is lurking down to the south. We can see that panning south into Texas. It's not so obvious in this area here, but we can certainly see it out to the east. Notice how we go from upper 60s right there in northeast Texas to mid-50s and even 40s further up north. So this looks like the front, and it probably connects back up into that triple point around, looks like around Plainview, Texas. And then down to the south, there's the tropical air coming onshore. 60s dew points and much warmer. So what you're seeing here, this is some of the stuff we go through on a severe weather day when we're doing a mesoanalysis and putting all the ingredients together. It's constructed the very same way. And some thunderstorms are expected today, mostly in northwest Texas down to the Caprock, and that's probably due to some slightly higher theta E's just ahead of that front as it comes eastward. And it'll probably trigger a few weak lines of thunderstorms later tonight. We can see that here on the WRF ARW. I'm going to run that forward from this morning. So you can see that this is the fuel that will be going into these storms later this evening, and we see that flow north towards where the frontal zone is. There's one front right there. There's another out to the west. And where they impinge on those fronts, we get some convection right through this zone right here. So that correlates pretty closely to the SPC risk area. As the storms get going, you can see the cold pools start developing. This is around 10 p.m. tonight. And then here we've got midnight. That's definitely a cold pool right there. And going a little bit further, we've got cold pools north of Abilene, south of Wichita Falls, and maybe a few around San Angelo. And then the main cold front, there it is coming south. Looks like the Pacific front located about right there. See those winds right there? They're coming out of the northwest at about 10 to 15 knots. So that's the Pacific air coming in from the west and the Canadian air coming in from the north. Ahead of that, the tropical air. And there's the Theta E ridge. So at 3 in the morning, going into 4 or 5 in the morning, this is the most likely location for any stronger convection. That's going to be just south of Wichita Falls, west of Fort Worth. Going into the dawn hours, we are losing the diurnal heating, so we're not going to expect very much, but there will be showers and elevated storms around. Then we can see that front moving quickly through the DFW area tomorrow morning, and then into the East Texas and Waco and Austin area during the day. Looks like those Theta E's have really built up. I don't know if we can bring up a sounding. Well, not with the ARW, but we can check the SPC outlook. And that's the outlook for tomorrow. Marginal risk correlating pretty closely to that Theta E ridge. And there's how the precipitation fields come together. There's 6 p.m., there's midnight. Some elevated cells coming south along that front, and you can see not much left tomorrow morning. Some redevelopment tomorrow near that Theta E ridge, and then things head southeast into the Gulf Coast region. And that's where they're expecting possibly a few stronger cells, maybe just after dark. And of course, it is bringing a little bit of snow there into the Abilene, San Angelo area, possibly all the way back to the Big Bend and back towards Chihuahua. So if I was looking to take some snow pictures in the Big Bend area, this may be an opportunity. Yep, 3-kilometer NAM, also going for snow back there, starting, looks like early tomorrow afternoon and continuing through the overnight hours. Look at that. That's quite a bit of snow down there. Let's look at the totals. Yep, that's a rare West Texas snowstorm there. Lots of 4 to 8 inch amounts there. El Paso not really getting much of it, but wow, out there near Sanderson, Marathon, and especially Fort Stockton, really pulling in some higher amounts on the NAM. And just checking the radar really quickly, there's the Lubbock radar picking up some elevated cells around Memphis, down towards Turkey, and up towards Shamrock. We can probably see that better on the Altus radar. A few more cells up towards Elk City, Mangum, Weatherford, but not particularly strong. And it's dark, so the infrared imagery is picked up from the visible, but running that back, you can kind of see what it looked like earlier in the evening. There's those elevated cells near that boundary. You can see the main push of Canadian air coming south. There's another sector right there, and things are just kind of unsettled and destabilizing. And then underneath you can see that large area of stratocumulus indicating the warm air advection coming up from the Gulf. Now, one thing that we've kind of lost sight of is all that snow being expected in West Texas, and that's due to that blob of cold air coming south through New Mexico and Arizona. That's going to undergo some evaporational cooling and some adiabatic cooling. Let's look at the visible imagery, because with this cold air advection into northern Mexico, we might see some interesting stuff. And there's the satellite for this afternoon in southern Arizona, northwestern Mexico, and this is very characteristic of cold core convection. That's some of the same stuff that was affecting Los Angeles yesterday. So now it's in the Tucson, Nogales area, and that is going to track eastward, and we're going to see that helping to set up the conditions for the snow event in West Texas. And there it is, winter storm watch from the western hill country back into the West Texas mountains. And I guess we've kind of overlooked that snow event up there in Iowa and Illinois, but what we're seeing there in West Texas is pretty rare. So I wanted to make sure we had some focus on that. And it's kind of hard to cover all of the country in a 15-minute webcast. But it looks like that event up north is quickly pushing eastward, and by tomorrow morning you can say that it's mostly over Lake Michigan, Lake Huron, and northern Michigan, and that's pretty much out of the picture by tomorrow evening. But that cold front will be coming south into the Midwest and down into central Texas. And that brings us up to New Year's Eve. Let's see what's going to happen then. Looks like a potent weather system down there in Texas. Wow. So we're looking at Thursday, New Year's Eve. I'm going to try to get some video of whatever happens around here. That's going to be the cold front. You can see the cold pool there over West Texas, and looks like maybe a warm front, something like that. I wonder if there's going to be some severe weather potential. I mean, we've got the warm sector right there, and we can see that track northeastward. So it looks like the GFS tracking some bands of freezing precip. Very fast moving, though, into the Midwest for New Year's Day. Some wraparound snow there in Iowa, and then things push up into the northeast U.S. Kind of a mixed bag up there in New York and New England. This is not a Arctic high. It's actually a low-pressure area and a lee side trough for January 2nd. And we get kind of a deep low-pressure pattern up there to the north. Things are quiet across much of the U.S. And then the next big change, that's probably maybe a winter storm across the Great Basin area into the Rockies on the 6th and 7th. And this is interesting. Looks like a system there off California getting a small taste of El Nino, even though we don't have El Nino. And yeah, that typically when we get stuff from California like that, you see what happens when it comes out of the east side of the mountains. Winter weather for the southern plains and maybe even some severe weather. So we'll keep an eye on that. That's still 240, 300 hours out. So that's all for our Tuesday edition of Forecast Lab. I thank you all for joining, and I thank our new Patreon supporters, Colton Ansell and Patrice Brown. Thank you for tossing in your support. It means a lot. Anyway, I'm going to leave you with this footage from yesterday's supporter stream, since we can't do any flights today. So check it out, and we'll see you tomorrow. Bye-bye.